Hi, I can see that you guys have a very interesting setup. So, welcome on stage, and you have now 18 minutes, and the stage is yours.
Okay, thank you very much. Appreciate it. This is a presentation. I'm Kevin Zanjani with Solid Energies here with Dr. Tim Lin. This presentation is on a novel solid state electrolyte and associated all solid state lithium ion batteries, we believe offering unprecedented performance. And so, our company's mission is to sustainably power society through safe, reliable, lightweight, and cost effective energy solutions. And what we're offering here is a particular type of technology that is sustainable, cobalt free, also using easily sourceable materials. And a technology that we've developed is a flexible solid polymer electrolyte, which offers a extreme low temperature performance that's fire resistant materials, as well as it's roll to roll ready. It can be produced with current lithium ion manufacturing processes, offering something that's streamlined in terms of manufacturing to reduce both the manufacturing time as well as complexity. And so, comparing other solid state battery companies out there, current roll to roll manufacturing is not really well suited for other solid state batteries that are being produced or it's going to be produced because they're using ceramics as part of the electrolyte, not very practical for roll to roll processing. Also, the temperature performance is very poor at low temperatures, less than 0 degrees Celsius. This is a big issue in terms of using the batteries in the automotive industry, especially in environments that require very low temperature operation. And so that's another issue with the other solid state batteries, as well as usability. They have poor rate capabilities, low critical current, as well as another issue is they require a very high degree of stack pressure in order to operate correctly. And in the automotive industry for electric vehicle applications, you have to build a lot of other surrounding equipment in order to support that. So it's not very ideal as in terms of that. So what we're doing is we're addressing these barriers and have developed a flexible polymer-based electrolyte that can be used for roll-to-roll processing and for streamlined fabrication. And so this is very interesting in terms of its applications for a solid-state battery. We're also offering a very high degree of safety. So if you take a look here, in fact, we've already built various types of formats, including coin cells as well as pouch cells. You'll see here a nail actually stuck through the cell. Nothing happens to it. We also, if you take a look at the solid state electrolyte, this is a polymer-based electrolyte. We're using a blowtorch here. The battery resists any kind of heat, fire, or any kind of thermal runaway. This is done in the laboratory. You'll see that on the bottom and afterwards as well. That's also another very important thing that's required in the industry for batteries is something that's extremely safe, either through puncture or any kind of extreme heat applications. Now, if we are comparing our solid state electrolyte, you'll see here our conductivity is within an order of magnitude of a liquid electrolytes, and we can operate up to about 90 degrees Celsius. We retain about 50% room temperature capacity at room temperature. We have 50% usable capacity down to minus 30 degrees Celsius when compared to room temperature as well. So other competitors that are using developing solid state batteries, they have to heat up the battery, right, in order for it to work to temperatures that are over 30 degrees Celsius. So you have to build a lot of other thermal management around the battery for the solid state battery to work correctly. We do not have to do that. With the Solid Energies proprietary electrolyte, we have this wide temperature operation of capabilities for these particular solid state batteries. If we compare it to other competitors on the market, we're able to do up to about 40 layers right now, 15 amp hours. No stack pressure, so about 1 atm in terms of operation. Temperature operation range from minus 40 degrees Celsius to 9 degrees Celsius. And in terms of energy density, about 350 watt hours per kilogram. Whereas other competitors, they require this high degree of stack pressure. They require the battery to be heated up in order to be working correctly. And the automotive OEMs have already explained that they need a battery that, can it work without the stack pressure? It's not very practical for us to build that, as well as a wide operating temperature range. That's also another requirement from automotive OEMs for using these batteries in the industry. So these are some critical items that we've already addressed as a company in terms of our development over the several years. And so for our particular solid energies electrolyte, we're providing the ability to